You may be asked to construct triangles to show that you can measure angles and construct lines accurately according to a specification. Now, to be able to construct a triangle, you always need to know 3 bits of information. So for instance, if you know how long the baseline is and you know what 2 of the angles are, you can extend these until they cross, and that will give you your exact triangle. This is called a side, an angle, and an angle, and we call this an ASA because it stands for angle, side, angle. Now, I would suggest you start by working out your middle thing first. I'm going to explain the other 2 types, and then what I'm going to do is actually construct some for you to show you how. The other one you might come across is a side, side, side. So you'd measure a side, and then you would draw the other 2 sides accurately with a ruler, and then you would use a compass to mark where each of those sides finish, and where they cross you would just join that intersection up, and that would give you the exact triangle. The other one you might come across is called a side angle side. Sorry, this is called an SSS triangle. So with a side angle side, okay, you would know one angle and then the 2 sides that combine it. So this is based on understanding the angle. So you would draw one side first, then you would measure the correct angle, and once you know that angle, you would measure that side to the right length, and wherever these 2 join up, where they end would give you your other side length. So this is an example of a side angle side triangle because it's given me 2 sides and 1 angle, and I've got 3 bits of information now that I can use to create my triangle. The equipment I'm going to need is a ruler, a compass, or a pair of compasses should I say. Compass means what you'd use for navigation with north, south, east, west on it. This is called a pair of compasses, okay, it's plural, and a protractor. Now, the first thing I tend to do to make sure I don't go wrong is I will measure this out on a separate line, and I'll also measure this out on a separate line and mark them accurately so that I don't make a mistake. The trick is to have a really, really, really sharp pencil. So I always make sure I have a sharp pencil, and the best type to use are a 2H because if they don't smudge, they give you a nice sharp line. So the first thing I'm going to do is measure a 7.8 centimetre line. I'm going to put a dot here and line it up, and I'm going to draw a 7.8 centimetre line, and I'm just going to put a little dot there to make sure that I've got an end dot and a start dot, and label it 7.8. And then I'm going to draw a 6.3 line starting with my dot and ending with my dot here, and that's my 6.3. Now that's going to make it much easier for in a second when I need to use my compasses, because I don't have to keep resetting my compass. I can, against the ruler, I can just do it from my lines. Now the trick is with the compass is to make sure that the point and the point of your pencil are in line, so just tap them gently on the desk and then tighten it as tight as you can. If your compass moves really easily like this one, you do need to get it tightened. Sometimes you can use something to tighten it quite easily. This one's a little bit too stiff. If needs be, ask your teacher to tighten it, or somebody at home to just use a Phillips screwdriver to tighten it. Okay, this is what we're going to do. We're going to just put 1 dot in the corner, and this dot is going to represent our angle and where our two lines meet. Now I'm going to take my compass and I'm going to set its point on the dot here and set its tip on the point here, and then I'm going to draw a semicircle around it. Now what that's done is it's given me an exact distance of 7.8 from my point. So I know that any line that I draw here will be exactly 7.8. Now what I'm going to do is just join my line up, create a line anywhere, and it can be anywhere you like, as long as you've got enough space to finish the diagram on your page. Then I'm going to put a point where that dot meets our arc. The other way you could do this, if you know you can measure really accurately, is just draw a line with 7.8. That's probably easier, but I'm just showing you how to use a compass so you get used to it. Now what I'm going to do is take my compass again, and I'm going to rest its point on one end of my 6.3 line and put the tip of my pencil on the other, okay? And I'm going to leave it to one side. Now, I'm going to need my protractor, okay? And because I've already drawn one line, I'm going to put my crosshairs at the end of it and my zero going down the line that I've just drawn, and I'm going to measure 65 degrees from this zero, so 65, so that's going to be there. Now, what you need to do now is just create a very long line, but very, very lightly, just so you know where that line sits. Now you need to take your compass again, pop the point on, and just draw another semicircle. Now what that semicircle does is it tells you exactly where 6.3 finishes when it's led at that angle. So I know that it finishes here because it intersects my 6.3 arc. Now I can finish my triangle by just joining my 2 points on my arc up. So I know now that this is 6.3 because this arc told me a 6.3 centimetre line. This line here is 7.8 centimetres, and this line, they might ask you to measure it, but usually they don't. And it doesn't matter what line this is unless they ask you for it, because they haven't specified here. They just need to get the marks. You need to know that the information they've given you, these 3 bits of information, is drawn completely accurately. So this is an example of an angle, side angle, triangle. Always start with the middle item if you can. So we're going to draw our 6 centimetre line first. So we're going to get, again, a really sharp pencil, and we're going to draw our 6 centimetre line on. I'm going to put a dot first so I can keep track, and then I'm going to draw another dot here, just a little mark. So that's exactly 6 centimetres. Now what I need to do is make sure I calculate a 13 centimetre line, 13 centimetre angle at one end and a 65 centimetre angle at the 65 degree angle at the other. So this time, if we're working from this end, we need to make sure that we're using this angle. So I'm going to run my zero down my line. So I'm going to use 13 degrees from here. So that's 10. And if I work up 1, 2, 3, because there's 5 degrees between each gap. So I'm just going to put a line there. And straight away what I'm going to do is just put a dotted line here for the time being. Okay. Now what I need to do is measure 65 degrees this way. So I'm going to put my crosshair on the end of where my dot is. I'm going to run this zero down this line. So I'm going to measure 65 this way, which goes here. And then once I've got this line, I can connect it up. Now notice that I haven't drawn this line far enough to cross this line. So I just have to extend it slightly. and where they cross will be what my triangle looks like. So I know that I have 65 degrees in here, and here I have 13 degrees. Now notice that this looks nothing like the triangle that they've drawn, but they've said that this is not to scale, so you don't have to expect your triangle to look like this. This is actually what this triangle should look like if it was drawn accurately. And just remember to label any other information they've given you. Job done. So this is a side, side, side triangle because it's not giving you any information about the angles. They just want you to base it all on the side lengths themselves. So this one, you're not going to use a protractor because there's no need for it. There's no angles to measure. So what we're going to have to do is just rely on our compass. So the first thing I would do is draw a side length of 3, another side length of 4, and another side length of 5, and I tick them off as I do them so I can keep track. So the first thing I'm going to do is I'm going to start with my bottom one, which I know is 4 degrees. So I'm just going to draw 4 degrees anyway, and I'm just going to put a little dot at the end of each line to help me keep track and label it. Not 4 degrees, 4 centimetres, sorry. Now what I'm going to do is again get a really sharp pencil, and I'm going to use my pair of compasses. Okay, make sure it's nice and tight. This one's a bit wonky, and make sure that your two tips are close to each other in length so that it makes it easier to manoeuvre. Now what I'm going to do is put my tip on here and here, and then because it's this side that I want it, I'm going to put the tip of my pair of compasses on this end, and I'm just going to draw a semicircle. Okay. Please, please, please get into the habit of only using one hand when you do these and keeping the other hand on your paper to keep it steady. If you use both hands to twist your pair of compasses, quite often you end up pulling your pair of compasses too far and it won't be accurate. By drawing the lines on your desk or on your sheet, you can always go back to check that you haven't accidentally moved it, making sure you've definitely got all the marks. Now, we've done 3, that's sorted, so I'm going to tick it off. I've drawn my 4, now I just need to do my 5. So I'm going to put my pair of compasses on here, point to point, edge to edge, and then I'm going to draw another line here. Okay. Now, where they meet would be where our two lines end. So this gives us a 3, 4, 5 triangle. Now the interesting thing is this is actually a Pythagorean triple. I know that when this is drawn accurately that we get a perfect right angle. Now that's because the hypotenuse, which is called C, when it's squared in a right angle triangle, the other two sides, the square of them added together, will make exactly the same amount. So for instance here, 5 squared, which is 25, is equal to a squared, which doesn't matter which side you use, I'm going to use 3. So 3 squared is 9, plus 4 squared, which is 16. Now notice that these two are exactly the same as this one, and any time that is true, you will definitely have a right angled triangle. And that is your first introduction to Pythagorean theorem. He's a great mathematician, absolutely fascinating. Kind of created his own maths cult.